Hey guys, how's it going? Today we're going to be learning about the ideal gas law, also known as PV equals nRT. There's a couple of terms that we need to know before getting into this, and these are super important because without them you won't be able to solve the problems. Also keep in mind that the units that each of these terms are applied to, those need to be the exact units that you use, or else the problem will not be right. And then if you have to convert accordingly. So the first one's going to be P, that's just going to stand for pressure, and its units are going to be ATM. Then you have V, which is just volume, and that'll be measured in liters. Then you have N, and that's the number of moles, and I'll just be using the unit mole. And then the gas constant is going to have the units of all the other terms on this list. So it'll have liters, atmospheric pressure, mole, and kelvins. And then the final one, temperature, that's just measured in kelvins. So yeah, let's just get right into it. We can do a quick little practice problem to start. So it says, given 2 moles of a gas at a temperature of 300 Kelvin and a pressure of 1.5 atm, what's the volume? So the first thing I check for is, okay, do we have all of the correct units? And in this scenario, we have moles, Kelvin, and atmospheric pressure. So I see no issue. So we'll start just writing our equation, which will just be PV equals nRT. And then from there, we just plug in. So 2 moles of gas, that's going to be for N. Then we have temperature, that's going to be T. And we have pressure, which is going to be P. And it says, okay, what's the volume? So we're going to set P, and then we are given, or we're not given volume, so it'll be V, and then N will be 2, and we'll have 0.0821, and then we'll have T, which will just be Kelvin, that'll be 300. And then from here, oh, and then I forgot one more, sorry, pressure is going to be 1.5. So now we need to solve for V, which is volume. So what we'll do is we'll just divide 1.5 to the other side of the equation, and then from there we can just plug it into our calculator super quick. That'll give us a value of 32.84, and since it's volume, it's going to be measured in liters. And then the units were K, this will be moles, this was ATM. And then I don't typically do the gas constant, writing all that out, because on a test, that's going to take too much time. And so you just kind of have to understand, okay, do I have what I need? Do I have the units that I need? And then just go from there, or else it's going to take too long on a test. All right, let's jump into our second problem. So for this one, it says, given a 2.5 liter container at a temperature of 27 degrees Celsius and a pressure of 1.2 atm, what is the value of N? Do the units match? If not, convert. And then calculate the number of moles of oxygen gas using PV equals nRT. So for this one, we'll just start and say, okay, so we have a 2.5 liter. So that, since it's liter, it's going to be our volume. And then we have a temperature of 27 degrees Celsius. And then we have a pressure of 1.2 atm. And then before we start the actual problem, we need to know, okay, do we have all the correct units? In this scenario, temperature is in Celsius. We need to convert that to Kelvin. And to do that, you simply just add 273.15 plus whatever your temperature in Celsius is. So in this scenario, it's 27. And that's just simply going to give us a Kelvin of 300. And then I'll just round it down to 300. It would be 300.15, but we'll just keep it 300. And then from there, we'll just plug and chug. So we'll say, okay, using our equation, PV equals nRT, 1.2 times 2.5 equals N, and R is going to be 0.0821, and then it's multiplied by 300, because that is our temperature, and from there we'll just solve for N. So we will divide this side by 0.0821 and 300, and then we'll divide the other side by 0.0821 and 300, and then these units will cancel out, and that'll help solve for N, and then we can just plug this into our calculator. All right, and that will give us an N value of 1.122 moles. And then there we go, and that is the moles of oxygen gas. If we wanted to convert that to grams, oxygen gas is O2, so that means there's going to be 2 molecules of oxygen gas. And so doing that and plugging in our moles, we'll have 0.122 moles. We'd set that over 1, and then there's going to be 32 grams per mole in this scenario, since there's 2 moles of oxygen gas. So we'd have 32 would be on top, 32 grams per mole. And then we could just solve that and multiply by 32. And that would give us 3.9 grams of oxygen gas. So if you wanted the mole, or if it was asking for the grams, that's what your answer would be. All right, let's move on to the last problem. So for this one, you guys can go ahead and pause the video and come back to this once you've completed it, and then go ahead and check your answers. And I'll wait for a second. All right, now that you guys are back, so for this one, it says a balloon has a volume of 5 liters at a pressure of 660 millimeters of mercury at a temperature of 20 degrees Celsius. How many moles of gas are in the balloon? So this one's a little bit more confusing. You guys see a term that you haven't seen before, which is millimeters of mercury. And for that, you're like, okay, what does that even measure? That's going to measure pressure. Well, it did say it right here. But yeah, so that'll measure pressure. Pressure is equal to 1 atm. Pressure this standard pressure is typically 1 atm. And 1 atm will convert into 760 millimeters of mercury. So in order to convert that value, we need to do 660 millimeters of mercury. Set that over 1, and then we'll say, okay, we're trying to get it to atm, so that'll be on top. And we'll put 760 millimeters of mercury on the bottom. We will cancel the units and get an atm value. And that would be 660 divided by 760, giving us a value of 0.87 atm. So there we go. Now we have our pressure. So our pressure is going to be 0.87 atm. Our volume is going to be 5 liters. Our temperature is in Celsius, so it'll be 20 degrees Celsius plus 273.15, giving us a value of 293.15 Kelvin. And then our R constant is going to be 0.0821. And then now we need to solve for N. So that is what we're looking for. So using the equation PV equals nRT, we will get 0.87 multiplied by 5 liters equals N multiplied by 0.0821, and then also multiplied by 293.15 Kelvin. And then from here, we can just plug and chug. So we will divide this side of the equation by 0.0821 and 293.15, and then divide the other side by that. And then we can just plug that into our calculator and get a value for N. All right, and I got N equals 0.181 moles. All right, guys, that's going to be it for today. I hope you enjoyed the video. If you have any questions, go ahead and drop them in the comments below, and I'll make sure to answer them. If you guys want to learn about anything else I haven't covered yet, feel free and let me know. And yeah, just go ahead and like, comment, and subscribe, and stay tuned for more videos like this. Have a good rest of your day, guys. Bye.